Good morning, good afternoon. Once again, it will depend on the time that you are joining the course. Today, we are going to start the advanced level of data analysis by using R programming. But we are starting to the inferential statistics as we have covered the descriptive statistics like the explanatory data analysis process in intermediate level. Now it is a time to see the inferential statistics, as we have seen that there is the difference between descriptive statistics and the inferential statistics. What we are going to focus on this, we are trying to run the advanced statistical modeling. So where also we are going to look for the advanced models, but also encouraging to take decisions based on the hypothesis testing. So that's why we started on hypothesis testing, because at the end of the day, we cannot understand how model or how statistical model also works without knowing the hypothesis testing. That's why we started on hypothesis testing, to understand that hypothesis testing, it is a testable proportion. We test that proportion. We test something so that we can take decision. And once we are testing something in mathematics, at the end, we come up with a model that is going to help us to validate or to explain the result we get from the test we have made or we are interested to do. As I'm giving you an example, let's say, for example, you say that maybe let's assume that there is a hypothesis says that the majority of female in Rwanda, they earn more compared to men. So those are also the hypothesis testing that you can say. And then from there, you will go to the field to correct the data. You come up with the data you get from the field, and then you make a model so that you can predict to what extent. There is a lot of variables, there is a lot of factors that you mentioned contribute to that hypothesis you state. Maybe the experience, working condition, the biological characteristics, adaptability, the types of the job they are doing. Those are the factors that you mentioned that is going to support you to prove your statement, prove your hypothesis. But you have to set the hypothesis before go there, and then you will brought the models. That's why we started on understanding the hypothesis, the assumptions of a hypothesis before we go to the model. So I think you understand what kind of hypothesis, why we started on hypothesis testing. Most people they will start on most people they will start on introduction, but for us we prefer to start on the inferential statistics. So without taking much time, let's go to the inferential statistics. So where we are going to look on hypothesis testing. In real life, we often need to make decision based on the population parameter. So if we say the population parameter, it is a value that describes the population. So the population, it is everything that can give us the data. The population, it's like a entire object that we are interested in to look for the information. Let's say, for example, if I'm interested to look for the female in Rwanda, so the population, it is entire females that is located in Rwanda, all females that is in Rwanda. That is also the value of the parameter. So the parameter, it's like a mean, it's like a mode, median, those statistical analysis. But when it applied to the entire interest of our study, we say it is a parameter. So, and if we take the sample among the population, among the female that are interested to look for in Rwanda, because I cannot reach to each female and everyone that is in Rwanda, so I have to take the sample. So those values I will get from the sample I take, it is what we call statistic. But if I use entire interest of our study, all of the participants, all over the context, all over the borders of our study, it is going to be the population. and the value that we will get, like a mean, percentage, those calculations that we will make, like a statistical calculations, it is going to be the parameter. So based on the population parameter, the hypothesis testing helps us also to make decision. And the hypothesis, the definition, it is promises or claim that you want to test. It's like they are promising something, or it is a claim that we want to test to see if it is true or not. So the types of hypotheses, we have two types of hypotheses. We have null hypothesis and the alternative hypothesis. So the null hypothesis, it is current acceptable value for the parameter. It is what we have in our mind, what we studied for. That's what we call the null hypothesis. You say that there is a difference between the salary of men and women in Rwanda. So those are the starting hypotheses. You say, for you can say that there is no relationship between the salary of a female and male, for example, are equal. There is no difference between the salary of men and the female in Rwanda. So that is the null hypothesis we're going to start from. And then for you say that there is a difference. That's why I'm going to conduct a research. The position where we are located, the position where we are supporting, the option where we are supporting, that's what we call alternative hypothesis. And it is donated by HA, while the null hypothesis is donated by H0. So it is an error here. It is H0, but alternative is noted as HA. So the null hypothesis, as I said, this is the simple definition. And also testing hypothesis, it is a process or the procedure that require a lot of evidence to reject the null hypothesis. What we have on the table before we go to the field, what people said before to go to the field. And that's why we go to the field to oppose or to prove if what the people said it is good or not. And the side we are supporting once we go to the field, it is also the alternative hypothesis. And we are testing the hypothesis. It is also the process or the procedure that's required a lot of evidence to reject the null hypothesis, to reject what is on the table, or to fail to reject the null hypothesis. So if you fail to reject the null hypothesis, it means that you don't have enough evidence to conclude that your side or your alternative hypothesis that you are saying it is true. Once you fail to reject the null hypothesis, you don't have enough evidence. So this means that once you reject the null hypothesis, then the alternative hypothesis takes place. And if you fail to reject the null hypothesis, implies that null hypothesis, it is correct. If you fail, it means that you don't have enough evidence. What the people said, it is true. It is still true. But if you reject the null hypothesis, you say that what people said, it is not true. Our position where we are having enough evidence that can support our position if you reject the null hypothesis. So without taking not much time, so there is also what we call the critical region and the level of significance. If we say the critical region, it is a range of the value for the sample statistics that result in a rejection of hypothesis. So the critical region, it is also the alpha equal 1 minus confidence level or the level of significance. So critical region, it's like I can say that it's like it's helps to measure the confidence of your result, to what extent, just in terms of percentage. So we used to say that the critical region, it is also the level of significance, or not level of significance, like the assurance, the percentage assurance of your result that you are going to brought in a table. Let's say, for example, you hear some people who say that 95%. That is also the range of our result where it's going to fall. That's what we call critical region. And this is an example. The company has stated their store machine makes something, and they are trying to show us how we can create also the level of significance. Level of significance is acceptable error we can make during the research. So the p-value, the method of also testing hypotheses. If we are testing hypotheses, we normally deals with those things: p-value, t-test, z-test, f-test, and whatever. But most of the time, I recommend you to use the p-value, because the p-value, I use it for the large data set. So most of the time when we are saying hypothesis testing and also the model as well, so we used to use the p-value when we are making decisions on the test that we have made. So the p-value, it is the level of significance chosen in another arbitrary. For the reason of most statisticians use the concept of the probability value to report the outcome of hypothesis testing. So the p-value, it is a standard error we can make that is acceptable for everyone. So the not the standard of error we can make. It is like we go to the field. I want you to understand this. Apology for that. So we go to the field, and if we go to the field, the p-value, what it means, there is a lot of error we can make since the process of correcting, analyzing, and doing something so that we can come up with our position or our opinion. So during that process, there is an error you can make as a person. There is an error you can make. Those errors, the probability of the error you made during that process, since you are trying to convince people to reject the null hypothesis, that's what we call the p-value. And the level of significance, it is the standard error that is set by the statistician so that it is going to be acceptable for each and everyone because of humanity. Because we are human, we cannot do something as a perfect as the way we want. But there is also the assumption is that as a human, the way we are, you can make an error. That's why the most of the time you will use to hear people say the level of significance is got to 5. So those 5%, those are the acceptable error we can tolerate. But the p-value, it is an error we made compared to what is tolerated. So if we make an error, those error we make, if we make the comparison between the error we make as a p-value and the acceptable error as a level of significance, and then we see that it is high or it is low, that's where we are going to make decisions. So those are also the way we take decision on this red sentences here. If the p-value, the error we made, is less than or acceptable, is less than or equal acceptable, or the alpha acceptable error, in this case we reject the null hypothesis. It means that our error we made, it is less than the acceptable. It means that the probability, what we are providing, our position, our alternative hypothesis, it is correct. And since the error we made, you see here, if the p-value, that is the probability of error we made during the process of getting information, if it is greater than the acceptable one, we fail to reject the null hypothesis. So we accept what null hypothesis also said. So those are how we can take decision. And also there is t-test. The t-test is used to compare the mean. We have 3 different types of tests, which is one sample t-test, 2 sample t-test, and pair sample t-test. So one sample t-test, it is used to compare the mean of one sample known standards. We use t-test when we have the smaller sample. So if we have the small sample, we will use t-test, and also if the population are normal, we will use also the t-test. So those are also the way, those are the codes we use when we are trying to do the t-test on hypothesis testing. We say t-test x, the value that we are looking for, and the mean that they are saying. One sample t-test in application, let's say for example, we have a product, we have a product of biscuit, and then we say that the average sales of the product called biscuit, it is 500. And then people, for you come up with saying that, let's assume that we are in a industry that providing the biscuit, not only biscuit and other kind of things, those different product, but we are focusing on one product. And then they put the statement that the average sales, average total sales in all the company, the biscuit, they contribute a road at 500 USD per day, for example. That is the hypothesis. For you, you come up with saying that, no, I'm not agree with that. So I have to find the position. Maybe you can say that it is less than or it is greater than. That's what we call one-tailed t-test. And if you say that, I don't know, I am not agree with what you are saying that the t-test is equal to 500 USD sales, average sales. But what I know, it is difference on that. You don't have like the position where you are located. So that's what we call two-tailed t-test. There is a difference. I don't know, but what I know, there is a difference between what you said and what biscuit is generating in terms of the total sales. So those are one sample test. You are focusing on one thing, either to accept it or not to accept it. So, and again, making the conclusion, we rejected the null hypothesis if the p-value is less than or equal the probability of error we made during the process. So not with a p-value, but also when we are looking for the t-test, we are not going to use the p-value. We are going to use T calculated and T critical. So T calculated, it is an error we made, and we use statistical procedures, and also the T critical, it is also standard one we base on when we are trying to compare with our result and the actual standard value. So based on the confidence level and the confidence interval or the level of significance as well. So otherwise we will fail to reject the null hypothesis if the T calculated is less than or equal what we get. So before we do this, we have to check the normality of our data by using Shapiro.test. So the Shapiro.test, it is a person who proposed that before testing a hypothesis, it's better to look for the normality of the data so that we are sure that our data are normally distributed. So if we say the data are normally distributed, what it means that they are that person or that data we have, they share common characteristics. What it means, let's say for example you go to the field and you collect the information about the behavior of a person, and you take people in Rwanda, you go in America, you go in Europe, and you say that those people are in the same basket in terms of the behavior. So you are making an error because they are in a different regions. They are not sharing any common characteristics regarding to the behavior, regarding to what you are saying. So, but if we say the normality, we are sure that our data are normal, which means if we are talking about the behavior, if you are saying in Rwanda, make sure that you are looking for the behavior of Rwandan people. All in common are Rwandans. But if you are mixing a lot of countries, you are out of the context of the normality. So we are saying normal because we want to assure that the participant, based on the response they respond, want to validate if they share some common characteristics, but also basing on the linked of the answers they provide. So to test the following, this is an example they give us, like we have the running score. These are the scores we get from the 13 students the score they get. So, and then we test the hypothesis where the mean learning score is equal to 85. And then for you, you can say that the mean learning score is less than or equal, and the mean learning score is greater than or equal. What you started, you have to start for checking the Shapiro dot test. And once you check the Shapiro dot test, null hypothesis, it is a normality. So to test the Shapiro, we are trying to look for this normality. And then if we are saying that the assumption of Shapiro, it says that null hypothesis says that the data are normal. You see, and the alternative data are not normal. That's why we are testing. And since we get the p-value, the way we take decision on the p-value always will be the same. Always the way of taking this decision will also the same. So that's why. So again here, once the p-value is less than or equal the level of significance, by default the level of significance, it is 5%. That is the standard error that is acceptable when we are doing the statistical for the social science, we can tolerate. But the p-value, we are trying to see what we made based on the tolerated value, and we take decision. Since the p-value is greater than 0.05, it means that our data are not normal. You see, our data are not normal because the p-value is high. So from the output above, the p-value is greater than 0, the null hypothesis is accepted. So data are normal, sorry. So it is accepted because the null hypothesis was saying that the data are normal, and the alternative said that data are not normal. So since we failed to reject the null hypothesis, it means that the data are normal. So, and then if the data are normal, we conclude, we proceed to testing t-test. So we do t-test, and then we continue. We say that x, it is also the score, running score, and then comma, we say the mean, what we are proposing, and then we are looking for the t statistics, which is, this is the t critical, and also this is what we get, or t calculated. So again, those are also the same for t-test. We are not going to take much time on it, but also we have another thing called the two-sample t-test, where two-sample t-test, we are trying to make the comparisons between, as considering the examples I give you, we are trying to make the comparisons between two products. Let's say we say the product A and the product B, and then we say that the average sales of the product A, it is higher than the average sales of the product B. That's why we will use sample t-test. So sample two sample t-test. So again, also the procedures are the same. We started on testing also the normality, but also the way we set the hypothesis. We can say that the mean of product A is equal to the mean of product B, or that is the null hypothesis. And the alternative hypothesis is saying that the mean of product B is greater than to the mean of product A. Those are also the assumptions, or you can say that I don't know, but what I know, it is a difference. That is two-state t-test. You are not specifying the position where you are located. That is also the sample t-test. And again, the hypothesis testing, also we are considering the following data to present the weight of women and the weight of men. Those are also, we are looking for the difference between two categories so that we can confirm if it is equal or not. So from that, we are trying to make the comparisons among those kind of things, and that's why we can accept, or we fail to accept that kind of things. And again, here also, we started on checking the normality by using Shapiro.test, and after doing it, we have also to accept this, or to fail to accept these kind of things. So without taking much time, the null hypothesis always doing accepting the testable proportion, but also there is another way you can use the hypothesis testing on what you are trying to do. So what I request you is just to read a lot on hypothesis testing, but also I advise you to to use the p-value when you are trying to take decision among what you are proposing to do, so that it be easier for you. And most of the time we used to play with the big data set. That's why we are trying to say that the p-value, it is the most option we can adopt when it comes to the hypothesis testing. So thank you once again for making this session to be happen. I think you enjoy it a lot. Let's meet to the regression analysis. After understanding what hypothesis is, we are trying to see some models that we can use when we are trying to confirm the relationship or to reject the relationship. So thank you once again.